Today's lesson is about the most important point that lies on the graph of a quadratic function. As you know, the general form of a quadratic function is the one that I made yellow on top of the page, y equals ax squared plus bx plus c, where a is not 0. In case that a is 0, it becomes a linear function, therefore we exclude 0 from here. Let's have a few examples. For example, let's choose a equals 1, so it becomes x squared, b 2 becomes 2x, and c negative 5, for example. Or let's choose a equal 3 x squared plus 3x minus 1. So we can choose the leading coefficient, which is a, to be a negative number. For example, negative x squared plus 5. In the this function, the last one, b is 0 because we don't have x. And the last one, like negative 2x squared plus 7x minus 1. These 4 examples are all examples of a quadratic function. So I want to know what the graph of these quadratic functions look like. This is why I'll go to my graphing calculator and I sketch the graph of some random, like with random coefficients. For example, 2x squared, as you see, is like a u that opens up. So y equals negative x squared plus x minus 1. Oh, it's like a u that opens down. So it looks like that if the leading coefficient is positive, it opens up, and when the leading coefficient is negative, it opens down. Let's try one more. So 3x squared plus 4x minus 1. Yeah, the green one that opens up. And the last example, negative 3x squared plus 4x, yeah, the purple one, which opens down. So there are, um, um, I think we can claim that all quadratic functions are either like a u, where they open up, and some of them, when the leading coefficient is negative, they like open down. Okay, so okay, I lost the page, so I found it again. Okay, so this one, therefore, is like this. This one also is like that. This one is like that. And this one also is like that. They are not identical, and we will see later on that some of them are narrower, some of them are wider, but the general optic is the same. So I'm going to write it here then. If a is larger than 0, the graph opens up. So it means the graph looks like this. And when a is less than 0, it opens down. Like this. So the most important point on the graph of a quadratic is the one that I make red here. See, all those points. These points are called vertex. So in case that a is larger than 0 and it opens up, vertex is the minimum to the quadratic function. And then when a is negative, where the quadratic function opens down, the vertex is the maximum. So this point determines the domain, range, axis of symmetry, and a lot of features regarding a quadratic function. Therefore, finding the coordinates of this point is a big deal. So I'm going to teach you how to find the coordinates of the vertex in a quadratic function. Let's start with a very important formula. So when y equals ax squared plus bx plus c, x of vertex is equal to negative b over 2a. So as you know, vertex is a point. Therefore, it has two coordinates, x coordinate and y coordinate. So this formula gives you the x coordinate of the vertex. You might ask, how are we going to find the y coordinate of the vertex? It's simple. Once you have x, if you plug in x, the what you get from here, then you can find easily y. Let me give you an example. So y equals x squared minus 4x plus 2. Okay, let's apply this formula. But before that, I would like to write here what are the values of a, b, and c. Actually, we don't need c in this formula. This formula depends on a and b solely. Therefore, a equals 1, b equals negative 4. Therefore, the x coordinate of the vertex would be negative b over 2a. I just copy the formula to be more comfortable with, right? So in this example, b is negative 4 and a is 1. Therefore, the x coordinate of the vertex would be 2. Now, I plug in x2 to see what is the y value. So I'm going to put 2 in this, the original equation, right? So y equals 2 squared minus 4 times 2 plus 2. Therefore, it's going to be 4 minus 8 plus 2, which is negative 2. Therefore, vertex has the coordinates of 2 and negative 2. So this is how we get the vertex. I'm going to give you another example. So y equals negative 2x squared plus 8x minus 1. So x of vertex can be written as negative b over 2a. b is 8. 2 times a is negative 2. Therefore, we will have negative 8 over negative 4, which is 2. So it means the x of vertex is 2. By plugging it back here, you will have negative 2 times 2 squared, 8 times 2 minus 1. I'm pretty sure that you know that exponents come first, so therefore it becomes negative 8 plus 16 minus 1. Therefore, it's going to be 7. Okay, so we have y, the value of the vertex. Therefore, vertex has the coordinates of 2 and 7. So another interesting case of quadratic functions is the vertex form. If a quadratic function is given as ax minus p squared plus q, you don't need to do anything to get the vertex, because vertex can be seen, and the coordinates of the vertex is p and q in this case. This is why we call that vertex form, because by looking at it you can determine what the vertex is. So y equals negative 3x plus 2 squared plus 7. So we are going to get the coordinates of the vertex. As you see, look here, you need to switch p, right? The sign of the p, because here p is negative, but in here p is positive. So therefore we switch p, but we keep q, because q here is positive. We also have it here positive in the formula. Therefore the coordinates of the vertex would be negative 2 and 7. We switched p, we keep 7, which is q. So therefore we have two different cases. Either you are given the general form that you use a negative b over 2a to get the x of vertex, or you are given the vertex form that is the easiest form for getting the vertex. So one more example and then we will be done. So y equals x squared minus 3x plus 2. So x of vertex, as usual, is negative b over 2a. b is negative 3 over 2 times a, which is 1, so it becomes 3 over 2. So now y would be 3 over 2 squared, 3 times 3 over 2 plus 2. So therefore y becomes 9 over 4. 3 gets multiplied and we'll have negative 9 over 2 plus 2. So we need common denominator. Therefore I'm going to multiply this by 2. Therefore we'll have 9 minus 18, which is negative 9 over 4, plus 2. If you put them together, it's going to be negative 1/4. So this is the y value of the vertex, and this is the x value of the vertex. Therefore, vertex has the coordinates of 3 over 2 and negative 1/4. The last example is this one, y equals 2x minus 4 squared. Let me change this to 2x. I'm going to change inside the bracket. So 2x minus 4 squared plus 1. This is a tricky question. This 2 here, does it affect the coordinates of the vertex or not? Let's make sure that this one is written in the form of the vertex form, because in the vertex form, if you look at the vertex form, the coefficient of x inside the bracket is 1 here. Therefore, that 2 must be dealt with. So let's take a look. So I can factor this 2 out. Therefore, it becomes x minus 2 squared plus 1. So then we can take this 2, that I make it yellow again, out. But we have exponent of 2 here. And as you know, if you want to take it out, we need to write it as 4, because 2 to the power of 2 is 4. Now we are one step away from finishing this question, which is 8x minus 2 squared plus 1. Now we can claim that this is in the form of the vertex form. Therefore, the vertex should be 2 and 1. So even though we tried hard to convert this equation in the form of a vertex form, but it looks that this is not necessary. And being having 2 inside the bracket doesn't affect the coordinates of the vertex, because if you look at the original one is 2x minus 4 squared plus 1. So if you set this one equals 0, if you set this blue one that I'm going to make it red. If you set this red one equals 0, so 2x minus 4 equals 0, therefore x becomes 2. And then you can write 2 as the x coordinate of the vertex, and q is 1. So you can get it like quickly like that, and you don't need even to convert it to a vertex form. Therefore, I come to this conclusion that even if a quadratic function is given as a kx minus p squared plus q, you can quickly get the vertex by setting this equals 0. So kx minus p equals 0, x becomes p over k, and the y value of vertex is q. Therefore, vertex can be written as p over k and q. Thank you for watching. We'll see you soon with another video about how to graph quadratic functions.